Jay Mitapalli, please call your friends and ask to join. Jay Mitapalli.
Yes, sir.
I will start within 2 minutes. Jay, whether the screen is visible and on board the words are clearly visible.
वशिम चालू झाला बघ. हा चेक कर थोडा तुझ्या मोबाईलला साइडला चेक कर.
Yes, sir. You are visible. You are visible.
So the written on board whether it is clearly visible.
Yes, sir. Yes, sir.
Right. Okay. Thank you.
हो थांबा. लेक्चर चालू आहे सरांचं 2 मिनिट नंतर नाही करा दुपारला. दफेदार सरांचं लेक्चर चालू आहे म्हणजे कसं आहे परत इथनं आवाज जाते सगळं.
Okay, in last lecture, we have started module number 1, ILD, influence line diagram for indeterminate structure. In last week, we have started this unit. In last lecture, we have seen what is meant by ILD, what is the difference between the bending moment diagram and the ILD. Then after that, we have taken one numerical, that is simply supported beam, subjected by one moving load, that is 1 kilonewton unit load, moving load on that particular simply supported span. Then we have calculated support reaction. For that support reaction, we have drawn ILD. Then we have calculated the shear force. For that shear force at particular point C. Again, we have drawn the ILD diagram for shear force. And last, we have discussed about the bending moment. So for same beam, we have calculated the bending moment, and then after that, we have drawn the ILD for the bending moment. Once again, I will repeat in brief whatever we have discussed in last lecture. Those who are absent in last lecture, they can write down this module number 1 ILD for indeterminate structure. So this unit already we have started in the last lecture. In last lecture, we have taken one simple beam, simply supported beam. One end is hinge, other is roller. Left support is your A, right support is your B. The span of beam AB is your L. So we have taken the load at point C, that is nothing but 1 kilonewton. Which is at a distance x from left support. As I told in last lecture, always take the distance from left support, that is from left support, that is x. So now I have to find out first the reaction at A, B. Then after that, I have to draw the ILD for reaction RA, then ILD for reaction RB. Then I have to find out the shear force at C. Then for that I have to draw the shear force at C. After that I have to draw the ILD at C. Then after the ILD for shear force at C, then I have to find out the bending moment. Then I have to draw the ILD for bending moment. In last class we discussed that. So for this beam, the value of RA is nothing but L minus X by L, and value of RB is equal to X by L. The value of RA, that is reaction for the 1 kilonewton load, that is unit load, that is moving load. So for that, I have calculated RA is equal to L minus X by L and RB is equal to X by L by applying equations of equilibrium, summation F1 and summation of M. So remember these two values of reaction, RA and RB. RA is L minus X by L and RB is equal to X by L. So after that, we have calculated, we have drawn the ILD for the reaction RA. So as I have put the 1 kilonewton, that is unit load at support A, so I get ordinate. Remember this term ordinate. We have to find out the ordinate of the reactions. So at B, ordinate is 0. And at A, ordinate is 1 for reaction RA. How it is done? So as you know, RA is equal to L minus X by L. If I have to put the X is equal to 0, so RA is equal to 1. X is equal to 0 is nothing but I am putting the unit load at support A. So X is equal to 0, that's why RA is equal to 1. 1 is nothing but the ordinate, right? So if I am moving the load from A to B, so at B, that is X is equal to L, so RA is equal to, okay, putting the value of X is equal to L in this equation, L minus 0, therefore RA is 0. So like that, we have to draw the ILD for the reaction. So what is this? This is your ILD for RA. ILD for RA. So this is ILD for RA. Similarly, we have to draw ILD for reaction RB. So as you know, the value of RB
YouTube म्हणजे आपल्या कॉलेज
is equal to X by L. So again, I am putting the unit load at support A. So X is equal to 0. So put this value of X in this equation of RB. So RB is equal to 0. And if I am putting the unit load at the support B, so RB is equal to 1. Okay. Use the value of RARB, put the value of X. Okay. As X is increased, RB also goes on increasing. If X is increasing, RB goes on increasing. So please draw this diagram parallelly. So this is your A, 0. At the ordinate of the reaction RB is 1. So this is your ILD for reaction RB. Right? This is the ILD for reaction RB. Remember this? So this already we have discussed in last lecture. So I am just brief whatever we have discussed in last lecture. So this is regarding the ILD for the reactions. This is regarding the ILD for the reactions, ILD for reaction RA and ILD for reaction RB. As I told in last lecture, what is influence line diagram? It is a graph or the plot which you have to draw for the reaction, for shear force at a section, bending moment at a section, right? For the unit load. Okay. So I think all of you know this, right? So now, next step is that we have to find out the shear force at section C. Then after that, we have to draw the ILD for shear force at the given section, that is section C, right? So, for calculating the shear force at C, consider the separate portion, that is AC and CV. So now, for finding out the shear force at section C, so consider the two parts. Okay, this is your RA. The value of RA is known to you, L minus X by L, and this is your RC. RA is upward, RC is downward. Okay, this is an equilibrium. The distance between A and C is your X, right? The next is I have to consider the remaining portion. Okay, for AC, RC is downward. For CD, it is upward. This span is your L minus X. So these are the two parts that we have to consider, left part and the right part of the beam. Why we have considered this at section C? Because we have to draw the ILD for shear force at a given section, that is at C. Okay, so for that we have to cut the section at point C, then consider the left side AC part and then consider the right part BC. So what we have to do now? I have to consider the 1 unit load over the span AC. Okay. I have to consider the 1 kilonewton load, that is moving load over the span AC. Now applying the equations of equilibrium, for the span AC. So summation of Fy is equal to 0. So Ra minus RC minus 1 is equal to 0. All of you please write down. Okay. Ra minus RC minus 1 is equal to 0. As value of Ra is known to you, L minus X by L minus RC minus 1 is equal to 0. So RC is equal to minus X by L. After simplification, you get RC is equal to minus X by L. Right? This is the value of RC for the span AC. For the span AC, this is the value of your RC. Okay. Now we have to consider the right side part of the beam is AB, that is CB part. Okay. Again, for span BC or CB, again I am applying the equations of equilibrium. Now I have to consider the 1 kilonewton load over the span BC. Now I have to consider the 1 kilonewton span over the BC. So again I am applying the summation of Fy is equal to 0. So RC minus 1 plus RB is equal to 0. As value of RB is known to you, that is X by L. So RC minus 1 plus X by L is equal to 0. In last part, we have calculated the value of RB, that is X by L. So now simplify. So RC is equal to L minus X by L.
Professor,
so this is the value of your RC for the left. So right part of the beam, that is PC. So for the left part, RC is equal to minus x by L, and for the right part, that is RC is equal to L minus x by L, right? So now we have to draw the ILD for the shear force at a section C by considering these two values of RC for the left portion and for the right portion. This is the support A, support B. Now we have to consider the value of only RC now, because we have to draw the ILD for shear force at a section C. So we have to consider the only value of RC for the left side AC portion and BC portion. So for AC, the value of RC is minus x by M, therefore it is downward. So draw the line as I told you last lecture. Okay, for statically determinate structure, ILD, that is influence line, that influence line is always straight, right? So it is minus x by M downward, and for right side RC is equal to L minus x by M, that is positive, so it is upward. So it is L minus x by L. This minus, this is the plus. So this is nothing but your ILD for shear force at C, right? This is the ILD for shear force at C. Okay, one is minus x by L and second is your L minus x by L, right? So this already we have discussed in last lecture also. Now, next part, that is for bending moment. ILD for bending moment. All of you understood? If any doubt, please ask. Now next, that is ILD for bending moment. As I told, first we have to find out the maximum bending moment which is below the load or at the center. Okay, so load is now at the C, so we have to find out the maximum bending moment at C. So for that, again we have to consider the left side and the right side part. So consider the AC. RA value is already known to you, L minus x by L. So this is RC. Distance in between A and C is your x. So now, taking the moment about point C for the span AC, that is MCA, is equal to RA into x. Taking the moment about C, so is equal to RA is known to you, L minus x into x, that is the moment at point C due to the reaction RA, right? So now consider the part CB. This is RC, RB. RB is known to you, x by L, and the distance is your L minus x. So for the span BC, the moment at point C, MCB is equal to RB into L minus x. So is equal to x into L minus x by L. So this is the bending moment which is maximum at point C, because we have considered the one unit load at point C, right? So now I have to draw the ILD for the bending moment. Remember this. Now I will take one example which is based on the last lecture discussion. So this is your maximum bending moment. It is x by L into L minus x. This is your A, this is your B. This is at point C, this is your x, L minus x. in last lecture, if you have to find out the bending moment at any other point, so by similar triangle, we have to find out that particular one. I will take one numerical, then you can understand better. Anyone doubt? Anyone having doubt in this? Find out that particular one. I will take one numerical, then you can understand better. Anyone doubt? Anyone having doubt in this? Okay. So I will take one example. First example, a simply supported beam AB has a span of 8 meters. Now we have to draw the ILD, draw influence line diagram for RA, RB, shear force at X and bending moment at X for section X. At a 3 meter, at 3 meter from left hand support. Right. Next numerical is a simply supported beam of span AB equal to 8 meter. We have to draw the ILD for RA, RB shear force at X and moment at X for the section at a 3 meter from left hand support. Means X is equal to 3 meter, which is given, right? So now we have to find out the reaction. Okay, span is 8 meter, X is given at a distance 3 meter, so remaining L minus X is 5 meter. Total span of beam is your 8 meter. Since suppose C, right? Now, first we have to find out the reaction RA-RB, then coordinates of the reaction for drawing the ILD, right? So, if I have considered 1 kilonewton load, if I am considering 1 kilonewton load at a distance from left support is nothing but y, and distance y from the left support, that is 1 kN load I am considering. So now I have to find out the RA and RB. So as you know, in last case we have calculated the value of RA and RB. RA is nothing but L minus X by L. So now X is replaced by Y. So L minus Y by L. And RB is equal to, previously it is X by L. So now I am taking the unit load at a distance Y from left support. So RB is equal to Y by L. Right? I am applying 1 kN moving load at a distance Y from the left support A. Always take the distance from left support, that is maybe X or maybe the Y. This we were discussed in last lecture also. So now the reaction RA and RB is in terms of Y and L. So RA is L minus Y by L and RB is nothing but Y by L. So now what we have to do? We have to find out the ordinates of these reactions RA and RB.
तुझ्या सिक्युरिटीची कार्य
Okay, ordinate is nothing but when we have to place 1 kN load is at distance A. So what is the ordinate of reaction RA? When we are putting the 1 kN load or unit load at a distance 1 meter from left support, then what is the ordinate of your reaction RA? Okay, so like that we have to prepare one table, then we have to draw the ILD. So first we have to write down these two values of RA and RB. RA is L minus Y by L and RB is equal to Y by L. Right? So now first ILD for reaction RA. First we have to draw the ILD for reaction RA, right? So RA value is equal to L minus Y by L. RA is equal to L minus Y by L. So for that, we have to prepare the table Y and ordinates of RA. Ordinates of RA. What we have to do now? Now we are drawing the ILD for support reaction RA. As RA value is known, L minus Y by L. Now, Y is the distance which is considered for the left support. As you know, L is equal to 8 meter. So now, if I am putting the 1 kN of the unit load at the support A, so Y is equal to 0. It is in a meter. If I am putting the unit load on a support A, so Y is equal to 0. So putting the value of Y in this equation of RA, so Y is 0, so RA ordinate is your 1. Right? Similarly, if I am putting the unit load at a distance of 1 meter, so Y is equal to 1. Okay, Y is equal to 1. And here is 8, so RA is equal to 8 minus 1 divided by 8 is equal to 7 by 8. Here is 8, Y is 1, so RA ordinate at distance of 1 meter is equal to 7 by 8. This 7 by 8. Now, at a distance 2 meter, I am putting the unit load, so is equal to 8 minus 2 by 8, that is 6 by 8. So at a distance 3 meter, it is 5 by 8. 4 meter, it is 4 by 8, that is 0.5. Then similarly, at a distance 5 meter from left support, ordinate of RA is 3 by 8. Then at 6 meter it is 2 by 8. At 7 meter it is 1 by 8. And at 8 meter is equal to 0. So these are the ordinates of reaction RA due to the unit load which is moving over the span AB. So what I have done, the formula of RA is known, L minus Y by L. So L is 8 meter. So putting the value of Y. So first I have put up the one unit load over the support A. So Y is 0. So putting the value of Y and L in this equation, I will get 1. Similarly, Y is equal to 1. When I am putting the one unit load at a distance of 1 meter from the support. Okay. So 7 by 8 like that. I have find out the ordinates of reaction RA. Okay. When the unit load is at the support B. Right? All of you understood? Anyone having doubt? Okay. So now I have to draw the ILD for reaction RA. By considering the table, okay. So at A, Y is 0, ordinate is 1. At B, ordinate is 0. One meter, then 2 meter. At 1 meter it is 7 by 8. 2 meter it is 6 by 8. 3 meter it is 5 by 8. At center it is 4 by 8. Then at distance 5 meter it is 3 by 8. At a distance 6 meter it is 2 by 8. At a distance 7 meter it is 1 by 8. And at support B it is 0. So this is your ILD for reaction RA. Influence of unit load over the reaction RA. Influence of the unit load over the reaction RA. So like this we have to find out the ordinates of the RA. Ordinates of the reaction RA at a various point. Simply consider at a distance 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, 6, 7, 8 like this. Okay, span is 8 meter. Okay, this is your ILD for reaction RA. Right? So now I will proceed further for second ILD for reaction RB. ILD for reaction RB. Similar way like we have done for the RA. So RB is equal to value is now Y by N. Y by N, that is value of your reaction RB. So similarly, we are putting the value of Y for calculating the ordinates of RB now. So Y and ordinate of RB okay, 0, 1, 2, 3, 4, 5, 6, 7 and 8 meter. So now put the value of Y is equal to 0. So it is 0. Putting the value of Y is equal to 1, it is 1 by 8. Then at a distance Y is equal to 2 meter. Okay, influence of unit load over the reaction RB. Okay, that is ordinate is equal to 2 by 8. It is 3 by 8, 4 by 8, 5 by 8, 6 by 8, 7 by 8, and lastly at distance over 8 meter, ordinate of RB is equal to 1. So like this, now we have to draw the ILD for reaction RB. So ordinate at B is 1, ordinate at A is 0, 0, it is 1. Now at a distance 1 meter, it is 1 by 8, at a 2 meter 2 by 8, at a 3 meter 3 by 8, at 4 meter 4 by 8, 5 meter from left support always, 5 by 8, 6 by 8, 7 by 8, like this. So this is your ILD